Today we are going to talk about specific heat. What is this specific heat? We will talk about this thing, and secondly, we will solve some problem related to it. So let me start with the specific heat first of all. When we are going to talk about specific heat, I just want to start with a very simple example. The word heat is actually here we use as a heat energy. Whenever we have used this is heat energy. So if I am talking about heat energy, I would like to start with one simple example. For example, this is a pot in which we have water. And how much of water is it in? It is, let's say, 1 kilogram of water is poured in it, and the temperature of the water, for example, initially it is 1 degree Celsius, and I want to raise it to a temperature, not one, let me make it 15 degrees Celsius, and I'm fine, and I want to increase this temperature to 16 degrees Celsius. So how much temperature is changing which I want? I need to change the temperature. Delta T is 1 degree Celsius. How I can change the temperature? If there is a burner underneath this, this is the burner, and this burner is having some fire. It has been ignited, and this fire is making heat. Now when we have this fire, it means we are trying to enter some heat in the water. Heat is being added. So whenever we talk about heat added, we use a symbol Q for the heat added. Okay, now whenever we have 1 kilogram of water
Salam
and
alaikum.
we want walaikum assalam, we want to raise its temperature up to 1 degree Celsius. So the amount of heat that we will add is called specific heat. So whenever I will define it, so I just make a diagram to understand the definition. So what is the definition? The definition is specific heat is it is amount of heat, amount of heat added in 1 kilogram of water to increase its temperature temperature through 1 degree Celsius rise. So temperature increase its temperature up to 1 degree Celsius. So whenever I use this one, that the amount of heat, if for example the amount of heat that is been added to this one for 1 kilogram of the mass of the water and temperature rises delta T. That amount of heat which I am going to add is called specific heat. Mathematically, I use this expression MC delta T. When I say that M is equal to 1 kg, I said that mass is 1 kg, delta T is 1 degree Celsius. So this C is called specific heat, specific heat, which is equal to Q is heat added. So whenever I will use this definition, so I will say specific heat is the amount of heat which is required to raise the temperature of 1 kilogram of water through 1 degree Celsius rise. So this is the amount of heat added. So when I want to find this C directly, I can use here C is equal to heat added Q over mass times increase in the temperature. So this relation can be used to find specific heat. Until now, in all of this discussion, I just use a definition from the book or that we usually use that it's 1 kilogram water if its temperature is something to increase it to 1 degree Celsius rise. So this is the amount of heat that we added with the help of fire or ignition. We call it specific heat. But what actually I want to tell you, this specific heat is usually a standard. What do you mean by standard? For example, I just say that I would like to say, just give me a minute. For example, if this is a pen, this pen, I say that this pen is 10 centimeter. Okay. If this is 10 centimeter and I make it a standard, so if I double the length, it will become 20 centimeter. If I half the length, it will become 5 centimeter. So this standard can be used to find any kind of length that is in centimeters or meters. Similarly, when I say that specific heat is a standard, so if we have the value of that specific heat, if we want to increase the mass, we can find this amount of heat required. We can also increase the temperature. We can find, for example, I say the specific heat of the water is C for water. Specific heat for water is 4186 joule per kilogram per Celsius. Per kilogram per Celsius is the unit. So please don't forget its unit. I didn't tell you earlier, but now I am telling you it is the unit. Okay, now if specific heat of water is 4186, what does it mean? It means that 4186 joule of heat is required to raise 1 Celsius temperature for 1 kilogram of water. What did I said? I said that this is a standard. This standard tells us that how much amount of heat is required to increase the temperature. As I told you that 4186 joule of heat is required to raise the temperature of 1 kilogram of water. My question to you is, if I want to increase 1 degree Celsius temperature for 2 kilogram of water, how much energy I need?
4186 times 2.
Very good, Khalid. We will need to done. If I need 10 kilogram of water and I need to increase the temperature 1 degree Celsius, so you will multiply it by 10.
10.
4186 times 10. Now I change my wording. Specific heat of water is 4186. If I have 1 kilogram of water and I need to increase the temperature of water, which is 20 degrees Celsius, from 20 to 40, how much energy I need?
You multiply it by 20.
Very good. If I have 10 kilogram of water and increase in temperature is 20, so what you will do?
Multiply it by 10.
And 20,
What?
because the temperature is increasing 20 and mass is increased to 10.
20. 10.
So you
Yeah.
will do 10 times. So now we found that this specific heat is a standard. That standard help us to know how much energy is required. And please keep it in your mind. The amount of specific heat for every, you can say, for any substance is different. For example, if I go to the other substance, like you can see in the table, aluminium has specific heat 900, ethyl has 2400, copper 390, glass 840, iron or steel 450, and so on, so on. For water, it is when it is ice, it is 2100. When it is liquid, it is 4186. Okay, so every substance has a different specific heat. Let me get back to the point. Now, the first question that we have is, this is example number 14.2. In example number 14.2, how heat transfer depends upon specific heat. First part, how much heat input is needed? What we have to find? We have to find heat input, Q. How much temperature is rising for empty 20 kilogram vat? So mass of the
Mass
vat is,
is 20 kilogram,
very
and
good.
we have
Temperature increases from
temperature
10
is
to 90.
10,
10 to 90 mean how much increase?
90 degrees. 90 degree, it could be 80 degrees.
80 degrees, very good. Now, they said that what is the heat input? So this is the vat. Vat mean a container in which we can have the water. So amount of heat required to increase the temperature of vat from 90 to 10, it is from 10 to 90, it is 80 degrees Celsius. How much? For that purpose, you know the formula is Q, amount of heat required to raise the temperature for the vat, QV for the vat, is equal to M C V for the vat and delta T. Here mass is given to you 20. Temperature is increased up to 80 degrees Celsius. Specific heat for the iron, because they said that iron is made up, vat is made up of iron. So for the iron, you can check in the table, it is 450 joule per kilogram per Celsius. This is joule. If you
Yes.
divide it by 1000, it will become kilojoule. So how much kilojoule?
Wait. 7.2
No.
divided by 1,000,
Yeah.
it will become 7.2.
Check again.
7.2000 divide, or we multiply?
Divide.
Divided by what? 1,000?
Yes.
Oh, now it's 720.
Okay.
Because I
So,
click answer, then divided by 1,000.
okay. This is the amount of heat that is required to raise the temperature of the vat from 10 to 90. Now, in part B, what are they saying? Can you read it, please?
In part B, we say, what if the vat is filled with 20 kilogram of water?
Okay. Now they are saying vat has 20 kilogram of water. So mass of the water is the same, 20 kilogram. Increase in temperature is the same from 10 to 90. It is 80 degrees Celsius. Specific heat of the water is 4186 joule per kilogram per Celsius. Now, how much heat is required now to increase the temperature of water? Q is equal to M C delta T. M is here 20, C is here 4186 for water. Increase in temperature is 80.
wait, it could be 6697600.
Can you divide it by 1000 to give it kilo? So I can approximate it 6700 kilojoule. Okay, now we have this amount of heat that is required to raise the temperature of the water. Okay, now you have only the iron vat. Then you need 720 kilojoule heat to increase its temperature from 10 to 90. But if it is filled with the water, how much heat it will require? It will require the heat to increase the temperature of the vat and the water. So total amount of heat, Q total, is equal to amount of heat required for the vat plus amount of heat required for the water. For the vat, it was 720 kilojoule, and for the water it was 6700 kilojoule. So the total amount of the heat required becomes 7420 kilojoule of heat. So this amount of heat is required to raise the temperature of vat filled with the 20 kilogram of water. Now, I just want to focus on these two results. Can anybody tell me why more heat is required to raise same amount of water than iron? Because you can see 20 kilogram iron, 20 kilogram of water. You want to increase temperature 80 degree for water, 80 degree for vat. So why you need more amount of heat to raise the temperature at the same level for same mass of water? Almost it is 10 times. If you can say this is 700 kilojoule, if you can say for vat, you can see here for vat you need almost 700 kilojoule, and for same amount of water you need 7000 kilojoule, which is 10 times, almost 10 times more. Less specific heat and more specific heat means, less specific heat means something will heat up quickly and cool down quickly. More specific heat mean that something will take more time to increase the temperature. It will absorb more energy, and when it will cool down it will release more energy. So water is a substance that has the maximum specific heat. It means initially water will not uh, become hot soon, but if it will become hotter it will take time to become colder as compared to other substances like iron. It will cool down and become hotter soon. For example, I want to give you an example, and similar time, same time I want to ask you the question: have you ever heard about the radiator of the car engine? The radiator of the car engine is actually the cooling system of the car. Whenever your car engine is working, what actually happening? Your engine is working and it becomes hot, and we need to cool it down. For that purpose, the coolant we use is water. Why we use water? Because when water passes through the engine parts, it takes more energy, and when it takes the energy from the engine becomes cold, and it will take more time to increase the temperature of the water until boiling. If there is some other liquid, for example, if I go here, if there is, for example, rather than the water, let me go down. Rather than the water, there is, let's say, ethyl alcohol. Ethyl alcohol has specific heat of 2400. It means it will become hotter in less energy, in almost half of the energy of the engine. For example, engine has some amount of energy. If water take 1 hour to heat up, so ethyl alcohol will take half hour and it will heat up. Similarly, if you use some other thing like mercury, mercury is having specific heat of 140. It means it will be 30 times sooner. You just ignite the engine. If mercury is as a coolant, it will take, for example, for water to 1 hour. So it will take only 2 minutes to heat the engine up. So what is the importance of this specific heat? Importance of this specific heat is water has maximum specific heat capacity. So whenever we use water, initially it takes a lot of energy to heat up. But once it is heat up, it takes too much time to cool down. That's the fact we use in heating system of different houses. For example, in the European countries, the heating system are not like the electric heaters or not like the solar heaters. Usually, we use solar heaters which has capillary tubes and water inside it. When heat of the sun make the water warm once, so it will take too much time to cool it down again, so the rooms and the house will stay warm for the long time because water will not cool down quickly. So this is a really interesting fact for the water being having a more specific heat energy. Okay, now let me move to the next question. How much is the mass? Usually 1 liter is considered 1 kilogram. So you can say 18 liter is 18 kilogram. Mass is 18 kilogram. And temperature increases from 15 to 95 between 80 degrees Celsius. And the cooling system has water. Specific heat of water, I told you, it was 4186 joule per kilogram per Celsius. So you have to find Q, how much heat is required, MC delta T. So multiply it 18 times 4186 times 80. How much difficult is it? Can I say 6.03 into 10 to the power how much?
No, wait. The number is 6027840. This is the
So
number.
how much? 6.03 into 10 to the power?
1, 2, 3, 4, 5, 6.
6
Yeah.
joules. So we can say that it is 10 to the power 6 joule. Now, when we are talking about the specific heat of the substances, question number 10, what is specific heat of the metal substance if 135 kilojoule of heat is needed to raise 4.1 kilogram of metal from 18 to 37.2 degrees?
Okay, first of all, the mass is 4.1 kg.
Okay, you have the mass.
Yes, 4.1.
4.1 kg. Okay.
And we make 37.2 minus 18, right?
Can you repeat, please?
I said we make 37.2 minus 18.
Okay, that is delta T.
Yes.
So 37.2 minus 18, it becomes, I think so, 19.8.
It will be 19.2.
19.2.
Yes.
Okay. Degrees
And
Celsius.
also we have 135 kilojoule.
So you have the amount here. Q is equal to 135 kilojoule. Kilojoule
Yes.
mean multiplied by 1000, so it becomes 135,000 joules of heat. Now you have
Okay,
this
then
amount
we
of
make
heat.
the equation, right? We apply
Okay,
the
you have to
equation.
find C. See here. So what is the equation for C? You know Q is equal to
1 second, so I'm having problem with my headphones.
Okay. We have this equation, Q is equal to MC
Yes, hello.
delta T.
Yes, yes.
So
Now
what
we
is
apply
C
it.
equal to?
C, 1 second.
Just move M and delta T.
Okay. C equal to Q over M delta T. Now we make 135,000 joules over 4.1 times 19.2.
Over 4.1 times 19.2. Can you give me the answer, please?
Yes, 1 second.
So 1715.
Yes.
And unit of specific heat is joule per kilogram per Celsius.
C. Yes.
So 1715 is the specific heat of the metal substance. Can you read the question, please? Question number 11.
Yes. How much energy is required to bring 1 liter pot of water at 20 Celsius to 100 Celsius?
Okay,
B.
that's it. The first part A is you have a pot. What is the pot mass? Did they give us the mass of the pot? No.
No.
They gave us volume, and I told you yesterday, whenever we have something 1 liter, it is almost equal to 1 kg.
1 kg.
Okay. 1 liter of water is always equal to 1 kg of water. So please, next time, if something is related to water in volumes, so you can simply say it is 1 kg. So how much is the mass here?
Mass is equals
1
to 1
liter mean
kg.
1 kg. Okay. So this statement.
Mr. Elad. What did you say again, Mister?
Yes, I am. Is my voice clear now?
Yeah.
Okay. I was saying that 1 liter mean 1 kg. Now, how much is the temperature rise? How much temperature you want to change?
80 Celsius.
Very good. 100 minus 20 is
80 Celsius.
80 Celsius. So this is 80 Celsius. Now, what you have to find in part A?
The energy required.
Energy is denoted by Q,
Q.
which you have to find. So what is the formula of
Q
the Q?
equals MC delta T.
Very good. So Q you need to find. You have M, you have delta T. What about C?
Oh.
This is water. For water, specific heat is 4186 joule per kilogram per Celsius. So try to memorize this one. For water, specific heat is this amount. So substitute the values and solve the question, please. Q is equal to, what is M? It is written
1 kg.
So it is 1 times C is how much?
4186.
And delta T?
Delta T is 180.
Simply 80. Okay. So multiply these values and give me the answer for energy Q.
334,880.
334,800.5?
80. No, without any
Okay.
points.
Without any points. 80. And the unit is joule.
Joule,
When
yes.
you round it off into two significant figure, it will become Q is equal to 330,000 joule, or you can say 3.3 into 10 to the power 5 joule.
Joule.